this video, we will have 4 examples of simplifying a complex fraction. A complex fraction is a fraction within a fraction, which sounds twice as terrible as a regular fraction, but it really doesn't have to be that bad if you're okay with simplifying and factoring. Also, we have to remember that when we're dividing fractions, again, this fraction bar, that's really a division bar. This means 7 over 18y divided by 2/9. And if we think about it as division, we can recall, or maybe learn for the first time, that dividing fractions means multiplying by the reciprocal. Flip the second guy and multiply. That's what I've always said. So this really means 7 over 18y times, multiplying by, the reciprocal of this fraction. Reciprocal just means flip. So the reciprocal of 2/9 is 9/2. And that's one way to look at it. I like this way because I'm more of a visual learner and it helps me to just see this in a less complex and crazy looking way. So now what you can do is just multiply straight across the top and straight across the bottom. However, you can make this easier on yourself by simplifying top to bottom, even diagonally, first. So 7 and 18 have nothing that can cancel. 7 and 2 have nothing that can cancel. 9 and 18 do. We can divide both 9 and 18 by 9. And now, 1 and 2 have nothing that can cancel. So now we can multiply straight through. When we multiply straight across the top, we'll get 7. Multiplying straight across the bottom, we'll get 4y. And just in case you might have missed something simplified here, you can double check in the last line. 7 over 4y is your final answer. Let's take a look at another example. This one looks a little crazier to start, but that's only because we do need to factor a little bit. But what I'm going to do first before factoring is just rewrite it. It's always a good first step. When something looks crazy, just rewrite it. So we can rewrite this as the first fraction multiplied by the reciprocal of the second. So the reciprocal of the bottom fraction would have x in the denominator and 15x plus 45 in the numerator. All right, now we can go about factoring, which I'll do in yellow. So x squared and x, those can't be simplified at all by factoring, but 5x plus 25 can. There's a GCF there. Same with this guy up here. So the GCF down here is 5, and we're left with x plus 5. So that's just a rewrite. And up here, the GCF is 15, and we're left with x plus 3. Great. So I'm going to rewrite in yellow down here. Let's see, we'll go down here. So now, right now, we have x squared over 5 times x plus 5 times the fraction 15 x plus 3 all over x squared. Oops, sorry, all over just x. Okay. Now we want to see if we can cancel anything top to bottom. All right, we first look at x squared. It cannot simplify with a 5, nor is it exactly the same as this. This is like one unit, x plus 5, because it's in parentheses and it's attached with the plus or minus sign. Nothing can cancel here and here. However, x squared and x to the first, that what they have in common is an x, and so we can cancel an x out, which means just take away this squared, and then this can cancel. That goes away. It just becomes a 1, all right. All right, let's take a look over here. 15, can 15 cancel with a 5? Yes, it can. They're both divisible by 5, and so this becomes a 3, and this becomes a 1. Then we want to see, can x plus 3 cancel with any other x plus 3s? No. Again, this x and this x cannot cancel. They're both a part of factors more than just the x. Okay, it looks like we've canceled everything that we can. Let's write our final answer in orange by multiplying straight across the top. So we'll have x times 3 and then times x plus 3. So I'm going to do 3x, x plus 3. In the denominator, we're left with 1 times x plus 5 times 1. You don't need to write a 1. And we're left with x plus 5. Quick check to see if anything else can cancel, and it cannot. All right, this next example looks even crazier because we have some things that look even more different, but we really just want to simplify the numerator and the denominator. Now, we want to get rid of these mini fractions in here, And the way that we can do that is we can multiply through by the least common denominator. Well, the least common denominator here is just going to be x. It's the only denominator that we have. So what we're going to do is multiply through every single term by x. So we'll multiply this entire numerator by x, and we'll multiply the entire denominator through by x. When we do that, we're going to distribute x to each one of these terms. So we'll be left with 2x, and then here we're multiplying x over 1, right? So this is x over x. That's just 1. X times its reciprocal, 1 over x, the x's cancel out. So anything times its reciprocal is just 1. Over here, we're going to multiply the x through. Same thing happens. We're left with 4x plus 1. Now we want to see, can anything else simplify? Can we take a GCF out of the numerator or denominator? No. We can't cancel anything here because these are part of a plus or minus, something more. Nothing else can cancel, and that is our final answer. All right, this last one looks even crazier. So we have a bunch of different stuff going on, and again, we have all these different mini fractions, so we need to multiply through by the LCD. We see that the denominators include 5 and x, so our LCD that we'll multiply through by is going to be 5x. So we're going to multiply every single term through by 5x, and actually I'll write it by each term instead so it's easier for us to see. So we're going to multiply each term by 5x. And really it's 5x over 1. I feel like that's unnecessarily complicating it, but I just want you to understand the 5x is not multiplying both this and this by 5x. It's multiplying this term by 5x, which is 5x over 1. Okay, then we're going to multiply these terms down here all by 5x as well. Okay, let's see what happens. Here, this 5 and this 5 end up canceling. If you don't see that right away, you'd end up with 35x over 5, and you would be able to divide by 5 anyway. So up here, we see that the 5 and the 5 cancel, and we're left with just 7x. We're left with a 1 in the denominator, but we don't need to write that anymore. The idea is to simplify these fractions and get rid of them. All right, over here, the x's end up canceling, and when we multiply, we'll be left with minus 35. Okay, down here, this 5 and this 5 will cancel, and we're left with x times x, which is x squared, minus, over here, this x and this x end up canceling, and we're left with 25. Okay, now we want to see if we can factor anything. The GCF in the numerator is 7, and we're left with x minus 5. The denominator is a difference of squares, and so it factors as x plus 5, x minus 5. And then the x minus 5s actually can cancel. The entire factor cancels. And our final answer is 7 over x plus 5. And there you have it. You now know how to simplify these scary looking complex fractions, but we now see that they're really not that scary.